Okay, Assalamualaikum and very good day to all of you. So today we're going to continue with the chapter 3 of this subject. Okay, so basically in chapter 3 is about the static of rigid bodies in two dimension. Okay, so for your information in this chapter we will divide the subtopic into two main parts, which is equivalent system of forces and equilibrium of rigid bodies. Okay, in order to summarize the chapter, okay, as I mentioned just now, the topic is divided into two main parts, which is equivalent of system of force and equivalent of rigid bodies. Okay, so let's take a look at the first one first, in which that about the equivalent system of force. So basically in this part, okay, we will learn how can we replace a given force, okay, with another equilibrium system of force. So how can kita gantikan force, okay, with another system which is considered as equilibrium. Okay, so for example we will learn how can we introduce a moment, okay, and we can calculate the resultant of the moment and resultant of the force in order to replace with the system which has a similar equivalent of force. Okay, and after that in the next part we will learn about the equilibrium of rigid bodies. Okay, so all the concept in this part will be applied in here in order to solve a problem as well. Okay, and however in this part we will have another three equation, okay, which is we can use to solve a problem related to the rigid bodies which is in equilibrium. Okay, so this is the equation which is a summation of fx equals to 0 and summation of fy equal to 0 and summation of the moment equal to 0. Okay, at moment at a point, okay, equal to 0. Okay, so if you still remember in chapter 2 when the object is in equilibrium, okay, remember that. Okay, so we consider that the object comply with this regulation, which is summation of the force or resultant force is 0. So in this case, for equilibrium of rigid bodies, there are another one additional equation, which is summation of the moment at that particular point is equilibrium. Okay. Let's begin with the first part first, which is about the equivalent system of forces. Okay, so before we can learn further about the equivalent of system of force, so we have to understand few things. Yeah, so such as external force. So basically there are two types of forces involved in engineering mechanics, which is external forces and internal forces. But however, for chapter 3, we will focus only on external force. So what is external force basically? So if there's any action, okay, on the external of the body, which is can cause the body to move or remain at rest. Okay, so for example, okay, if you have a box on a plane surface, okay, and we apply a force, okay, to push the box slightly, okay, so the force which is caused the box, whether it is moving or remain at rest. Okay, this is what we call external forces. So when we draw the free body diagram, it will look like this, which is refer that this force is actually considered as external forces. Okay. Meanwhile, for internal forces, is actually the force that can cause the two parts hold together and forming a rigid bodies. Okay. And let's take a look at this lorry. Okay, so this lorry, okay, can you identify where is the external force towards this lorry? Okay, so first, of course, since that this lorry is being pulled by these three men, so there will be a force pulling in this direction. And not forget that this lorry, of course, has a weight of the body, so it has kind of gravitational weight towards downward, and then it has a force when you know that this surface, this tire touched towards the plane surface, so there will be a repulsive force back on the tires, which is R1, and the tires at the back as well, R2. Okay, so the free body diagram for this force involved on the lorry will look like this. Okay. Oh yeah, so sorry, I just changed the notation. So this one will be R2 and this one will be R1. All right. Okay, so what is moment of a force about a point? Okay, so basically the moment is actually the results from the force that caused the body to make rotation. Okay, the simplest example, okay, that I can relate with your life is like a steering on a car. Okay, so for example, okay, you want to turn your car towards the right direction. Okay, and your two hand holding on the side of the steering wheels. Okay, so since that you want, in order to move that car to the right direction, okay, so you need the steering to rotate on clockwise direction. So what happened is you apply a force by using your hand on your palm on the side of the steering, and then when you apply the force, okay, it causes a rotation of the steering. Okay, so when the rotation is happen due to the force which is applied towards the rigid body, so that is what we call a moment. Okay, so if you can see from the definition here, the tendency to rotate is caused by a moment. Okay, so whatever object, when we apply a force and it has a tendency to rotate, so the tendency to rotate itself is called as a moment. Okay, there are two categories of the moment, which is whether the moment is positive or negative. So how can we identify whether the moment is positive or negative moment? Okay, let's take a look at the first one. Okay, so this moment is considered as positive moment. Why? Okay, so this is actually look like a spinner or something like that. Okay, so you apply a force here. Okay, so when you're pushing this object, a spinner, okay, so this thing will move or rotates in anti-clockwise direction. So when it moves on anti-clockwise, okay, anti-clockwise, it becomes a positive moment. Okay, I repeat, when the moment or rotation is in anti-clockwise direction, so the moment should be the positive moment. Meanwhile, for the negative moment, it is actually due to rotation which is in clockwise direction. Okay, so for example, you apply a force at this point, which is cause this spinner will rotate in clockwise direction. So when it's rotate in clockwise direction, it is known as negative moment. Okay, so here is the summary, okay, about the moment sign and the moment direction. Okay, so the positive moment, it should be anti-clockwise, and the negative moment should be clockwise direction. Okay, Okay, let's try this example one, okay, about the moment, okay. So here it shows that a 100 vertical force, okay, this is actually the 100 vertical force, okay, which is mentioned by the question, is applied to the end of a lever which is attached to a shaft O. Okay, so this is the lever, okay, and then it's attached to a shaft O. Okay, so we can know that this is actually the reference point for this moment, okay, for this force. Okay, so the question asks you to determine a few things here. Okay, so let's take a look at the first one. So determine the moment about point O. Okay, so what is the moment due to this force towards point O, which means that the reference point for question A is point O. Okay, so that's the question A. What about the question B? Okay, in question B, it stated that the horizontal force at A which create the same moment. Okay, so what does it mean by question A is that you replace the force here, which is in vertical direction, into horizontal force. So this one is vertical, so horizontal is like this. But we don't know yet whether the force should be in this direction or the other way of direction. So how can you check whether the direction is correct or wrong? Okay, so in order to produce a moment, we should consider that the moment produced at A will be the same as the moment produced at B. So for example, if at A, okay, you get like the moment value is like maybe 100 Newton meter and positive moment. So at A, you also expect that you get the same value of the moment, okay, the same value of moment that you get at A, and the same direction. If it's positive, so it is anti-clockwise. Okay, so how can you create the same moment and the same direction with this force, with the new force, which is located still at A, but in horizontal direction? Okay, so I hope you clear about question A and question B. What's the difference? Okay, and then question C. Okay, for question C, it asks you to determine the smallest force at A which produce the same moment. Okay, so for just now, okay, question A and question B, okay, the value of the moment is stated here that it should be the same. Okay, same goes to question C. It requires you to calculate what will be the smallest moment. Okay, that means the F will be minimum, the smallest force, which is can apply somewhere at A here, okay, in which that it will produce the same moment, okay, which means that moment that you calculate at A will be equal to moment you calculate dekat B, and sama juga moment you calculate dekat C. However, dekat A dengan B, okay, the force is known, okay, but for C, the force is not given, but it's stated that you should have minimum forces. Okay, and take a look at the question D. Okay, location for a 240 vertical force to produce the same moment. Okay, so dekat D pula dia tanya where to locate the force. Okay, if you want to produce the same moment, tapi okay, dia punya F now, when F if is actually 240 Newton in vertical direction, but we don't know yet where to locate. Maybe dekat somewhere here or somewhere here, I don't know. Okay, of course it may be somewhere along the level here. Okay, and question E, whether any of the forces from B, C and D is equivalent to original forces. Okay, so adakah force yang kita calculate dekat from B, C dengan D ni, ada tak yang at the end dia F dia sama juga dengan F dekat A tadi. Okay, F that you get from question A ni. Okay, so let's take a look one by one. How can we solve this question? Okay, let's solve question A, okay, in which that we need to determine the moment at point O due to the force which is at point A. So from this diagram, okay, the reference point, okay, because this question mentioned clearly moment about point O. So therefore the reference point should be the point O, okay. So what will be the rotation or moment due to the force at A, okay. So the way, the easiest way to imagine where is the rotation, you just imagine that you are locating kind of like wheel here at your reference point, okay. So this wheel is being applied with the force in this direction, okay, same direction of force at A, okay. So of course this wheel will turn into clockwise direction. So therefore, this moment will be negative moment because it moves in clockwise direction. Okay, so we know that moment is equals to F, the force which is applied to the point, okay, and then times with the perpendicular distance, okay, the perpendicular distance um, from the line of action of the force and the reference point. So let me draw it. So for you to be more easy for you to understand. Okay, so we have this lever, okay, and the reference point at O. So we know that the line of action of force is actually at this direction, which is in a vertical direction. Okay, so what does it mean by perpendicular distance? Here is actually the perpendicular distance is from the line of action towards the O. So basically it is located here. Okay, this is perpendicular distance which is between the line of action and the reference point. So this is our D. Okay, so can we get the D value? Okay, of course, yes, because that you know that this is the distance here provided 0.24. Basically, it is in cm. So I just convert directly into SI unit, okay, which is 0.24 meter. And we do have this angle here, which is 60 degree. Okay, so the D here is actually 0.24 times with the cos 60. Okay, and you will get that the answer for D. Okay, and once you get this D value, you just substitute into this formula, and then the force here, which is 100, you will substitute this value into this formula as well, and you will get the value of M directly. Okay, let's take a look. Okay, so the distance, perpendicular distance is 0.12. So basically this one is 0.12. Okay, so once you multiply between the distance and the moment, and you will get the answer is negative 12 Newton meter, which is in clockwise direction. So that's why it has negative. So that's it. Okay, so for question A, okay, the question asks you to determine what will be the horizontal force, okay, at A, in which that it will produce the same moment as A. Okay, so if you remember at A, the force is given, but for this question, the moment is given because it wants the same value of the moment that we calculate in A, which is 12 Newton meter. Okay, so the only things that we want to determine is actually the force itself. Okay, the here force at here. Okay, so we know that moment is equals to F times T. Okay, so the moment is already known from A, which is equals to 12 Newton meter, and the force is the value that we want to determine. Okay, and the distance. Okay, so since that the question mentioned that it is located in horizontal direction at point A, so this is the horizontal direction, and this should be the perpendicular distance. Okay, let's do it. How can we determine the perpendicular distance? Okay, and this is the point O again. Okay, and now the direction of the moment is in horizontal direction. Okay, so therefore what will be the perpendicular distance? Okay, this is the line of action for this force. Okay, and so this is the line of action for our reference point. Okay, so the perpendicular distance between the force and the line of action of the reference point is here. Okay, D2. I label as these two because I don't want you to confuse with the first one. Okay, okay. So therefore, we know that this is the 0.24 meter and we still have the same angle. So at this time, our D2 is actually 0.24 times with the sine 60. Okay, so this value you just substitute into this one. Okay, and you will get what is our F value. Okay, so once we get the F value, okay, let's take a look what will be the F value. Okay, so this is our F value, 57.69. Okay, not to remember that, okay, we want our force our force will produce the negative moment, because remember that from A it should be negative. So how can we know whether the force should be in to the right or to the left? Okay, so in this case it should be to the right, because if we put it this way, okay, imagine that this is a wheel. Okay, only if we locate it to the right, it will produce the negative moment. Okay, so which will be equal to the one that we get from the A, because it is stated that the same moment as A. So the same terms here means that the value should be the same and the direction should be the same, which is negative. Okay, so let's imagine that if we put in the other direction. Okay, so imagine that the force is the other direction. Okay, so imagine that this is the wheel and then you put the force in this direction, in opposite direction. Okay, so what will happen to this wheel? Okay, so if you just push it, it will rotate in anti-clockwise, and that will be positive moment. So it's not the same as we get from A. Okay, so you have to differentiate how can we get the positive or negative moment. Okay, that's it for question B. Okay, so now let's continue for question C. Okay, so for question C, okay, the question asks you to determine what will be the smallest force at A to produce the same moment that occurs, okay, at from question A and question B. Okay, so we want the same value and same direction of the moment. So we know that from question B and question C, okay, our moment value at point O is actually negative 12 Newton meter. Okay, so how can we produce the same value of this moment, okay, and the same direction, but the force will be the smallest force? Okay, so we know that M equals to F times perpendicular distance, and the M now is fixed. Okay, the value that we can play around is only F and D. So how can we make sure the F here will be the minimum value of F? Okay, so from here we can make correlation between F and D. Okay, so from this equation we know that F will be uh, inversely proportional to D. Okay, if we bring the F or D to the other side, so it will be inversely proportional to F uh, and D. Okay, so F will be inversely proportional to D. Okay, so if we want that this F will be minimum, the F should be maximum. Okay, so if we draw back again the diagram here, okay, it is a reference point here, okay, and the force should be at point A, but we don't know the direction, whether it's supposed to be vertical, horizontal, or other things. Okay, so we just make like this. Okay, so by looking at this, okay, the perpendicular distance towards O can from point A can be three ways, whether this one or this one and this one. So in order to make the perpendicular distance is the most or the highest one, okay, we should choose this distance. Okay, so in fact if we look at question B and A, okay, the distance for A is actually 0.12 and this one should be 0.208, in which that we get this one from question B. Okay, and this one 0.24. So of course with the maximum value of D, we will get the minimum value of F. So in order to make this one as a perpendicular distance, the location of the force, okay, should be like this. Okay, so that it will become perpendicular distance. Okay, so this is actually the perpendicular distance for us. Okay, so we already know that the D will be equals to 0.24. So we know already the value of M, and we just substitute the value of F. So F will be what? Okay, so let's take a look at the solution. So from the calculation, the F will be equals to 50 Newton. Okay, and towards this direction in order to make the moment into negative moment, which is clockwise moment. Okay, that's it. Okay, now let's move to question D, in which that we need to determine the point of application of a 240 Newton vertical forces to produce the same moment as A, B, and C. Okay, and we know that the moment that we produced before is actually the negative moment, okay, which is the value is negative 12 Newton meter. Okay, and we do have the information at this time, which is the force is actually 240 Newton, where the force in vertical direction. So of course, if we want to produce the negative moment, in this case, okay, the direction of the force should be downward, so that the rotation will be clockwise rotation. So we already can predict the direction of the force. Okay, so however, where to locate this force in order to produce this value of the moment? Okay, so let's take a look at this diagram. Okay, so we know that this is our reference point and this is A. So we should place this force, this vertical force, along this lever only. Okay, but where to locate? Okay, so let's say that we don't know the distance yet, but we only knew that it is in vertical direction and with the force is 240 Newton. Okay, so if the force is in vertical direction like this, okay, so where is our perpendicular distance, the D? So just draw the line of action along the force of A and then get the perpendicular distance from this line of action towards O. So here is actually the perpendicular distance and D is somewhere here. Okay, and we know that this is the angle 60 degree. Okay, so the perpendicular distance is actually this distance, but when we want to locate somewhere here, okay, we should know exactly where is the distance, okay, along this lever. But before we will able to get the distance along this lever, we can determine first the D value. Okay, so basically we want to know this distance, this length. Okay, so before we can get this L, we have to get this D value. Okay, by relate it back with the moment equation. Okay, so moment equals to F times T, and F in this case is 240 and the moment is 2 Newton meter. Okay, and the force is in Newton value, and the D is the value that we are looking for. Okay, so we don't know the D value. Can we get the D value? Yes, we can, because we can solve this equation and we will get the D value. So in this case, what will be our D value? So we just substitute into the formula, okay, and get the D value is actually 0.05 meter. Okay, have we done yet? No, not yet. We still need to get the L value, because this one is actually the perpendicular distance. We want to know where is the point along the lever. Okay, so draw it again back. Okay, so we have this D value, which is 0.05 meter, and we do have the angle here, and this is the distance that we are looking for, the L. So the L can be what? Okay, so by utilize this angle given here, we know that the cos 60 is actually equals to 0.05, which is the adjacent, divided by L. So L should be 0.05 divided by cos 60. Okay, so we will get that the distance L here should be 0.1 meter. Okay, so the distance here the L here should be 0.1 meter or equals to 10 centimeter. Okay, so basically what I can summarize is that we need to know what is the formula to calculate the moment, and we should know how can we calculate the D here in this case, the perpendicular distance. Okay, so once we already know where is the perpendicular distance, okay, we can bring back to the diagram, okay, and to relate back with the location along the lever by using concept of trigonometry. Okay, so that's it. Thank you. Okay, so last one, question E. Okay, for question E, it just asks us to identify any of the answer, any of the force which is at part B, C, and D, which has the same force as question A, which is the original force at question A. Okay, because that from A until question D, okay, all the moment is the same moment, which is the moment that we want to produce is actually negative 12 Newton meter. So the question asks us to identify is there's any force at B and C and D which has the same value of the force as question A. So which is A as 100 Newton. Okay, so the answer is no. Okay, because that even though it has the same value of the moment, but the force at B, C, and D is not the same as a force which is 100, because that that moment equals to F times D. So if we change the location of the force, okay, it may affect towards the D, even though the moment is fixed. Okay, so in our case, moment is fixed. So the only difference is F and D. So if you notice that B, C, and D, all of it has different location or the distance, the perpendicular distance. So therefore, F will be changed towards the change of D. Okay, so I just revise back again, okay, where the point of F is different or the direction of the F is different. So that's why it may cause change on D. This one is for question C, this one is B, and this one is D. Okay, so that's it for this example. And see you in the next part.